Hey everyone! Today we continue with our course named Mastering Reusable Solutions for Revit Plugin Development. In previous sessions, we explored data structures, the iterator pattern, its implementation in C Sharp, and also we've created a geometry domain, right? So things like curves, solids, and other things related to the geometry part, to the data. I highly recommend checking those out before diving into today's video because they go in order, so it's important for you to understand what is going on. You can also find all videos in the playlist called Mastering Reusable Solutions for Revit Plugin Development in my channel, and everything is in order, so it's important that you can kind of watch one by one. In this episode, we will begin creating an implementation for the flatten method. We'll cover numerous useful topics such as writing code using the task-driven development approach. You'll become familiar with the testing framework and discover various strategies for solving a problem incrementally. Then we will refactor it without fear of breaking your code. So that's kind of the main point. So we discover how we can write code using TDD, test-driven development. We learn about testing framework that allows us to set up an environment where we can write code. And then once we have everything set up, we can refactor our code without the fear of breaking it. Additionally, we'll explore the yield keyword in C Sharp, its underlying implementation, and how we can apply functional programming in C Sharp to enhance the readability and elegance of your code. So there will be a lot of valuable insights that you can take and implement that in your Revit plugins that are kind of pretty important in software development. So they will help you in implementing features with more confidence. Before we begin, please take a moment to like this video, subscribe to the channel, and leave your thoughts in the comments below. If you're interested in more comprehensive courses, be sure to visit my website that is in front of you. You can also follow the link that is provided in the video description. Let's get going. So now it's gonna be completely about practical stuff. So let's get started. I'm following TDD, test-driven development, and I don't want to go too much in depth of it, and probably right now you have no idea about what it is, but I'll hope that it will make it clearer. So as you can see, currently we are in the project that has tasks in it, and it has some kind of weird things like near classes. It has some marks, some visualizations that allow us to run this, debug it, and so on and so forth. And also it can allow us to run them, right? So I can click and say run all, and it provides us a way to visualize if something is working or not. So yeah. So this is going to be, for the time being, think of this as as our environment where we write code. So I don't want to write everything in some console application. I want to use this testing environment where I could put things and do stuff. So what I usually start is that I write a list of things that I would like to test. So I always have some way of organizing it. You gotta make sure that you have an environment where you can put your ideas into. For example, here I'm not gonna like show everything, but in my case, I'm using Notion. I have programming problem solving page where I have different kind of pages where I solve various problems. So that can be from my Revit API course, like Revit development, AutoCAD development from where I work, from Dynamo, and I have for videos, right? And this is where I kind of put different thoughts that I have. It's really important that you're not just writing code, but you're actually thinking about what is going on. So make sure you have environment where you can put your ideas and just understand what you're going to do about this. So the first thing that we're going to do is that we're going to implement something that will allow us to kind of flatten the geometry element. And let's kind of understand the problem of this, right? So far, it's usually what you can get out of Revit. So when you have an element and you get geometry element of this, you can get a structure like this, right? Where it's like a tree-like structure. And the problem with this is that sometimes we don't want to work with like these things like geometry instance or another geometry element that can happen on the way. We only want to get curves, solids, curve, solid, solid, and so on. Because right now, for example, let's suppose you are um, working on a project and you need to get solids. In a very like imperative way of doing this, I'm not gonna go too much technical and versus like imperative versus declarative, but our main goal is that we move from imperative to declarative style of coding. So imperative is more about where you say how things should be done. Imperative is about saying, declarative is about saying what we want. Imperative is about saying how things should be done. It's again, these things are better explained by showing. Let's suppose you go with the geometry element, that instance that we have, right? Geometry element. And since that implements IEnumerable, we can use this in the for each. You already know that behind the scenes, for each is just a syntactic sugar. So using writer, if I go to IL viewer, it's actually, let's go to low level, so it's at least somewhat more understandable. So for each translates into something like that. So keep in mind that whenever you use for each, it's seen by the compiler differently. So and you say you want to get solids now. Let's kind of debug it, just do some silly things like this, right? I don't know, or like, so we kind of go inside of here. So I'm gonna put a breakpoint. I know it's silly, just to see what we're iterating over, right? So if I go here and click debug, it will start a debug, but I'm gonna click Control UD, that's the shortcut for this. I like use shortcuts, so make sure you also learn them. So as you can see here, the first thing where you get is that it's actually null. Oh, okay, because we go for each. Okay, it's not. Yeah, why it's null? Yeah. So the first one it hits is the geometry element, where it has. It's kind of interesting. Let's go over this again. I think it was. Oh, for God's sake. Yeah, that's funny. Because that should be geometry object. I'm not looking at this correctly. Um, I think we could have just printed them. I think, yeah, this kind of framework, testing framework has it, but I just want to show it as simple as possible for the time being. So as you can see now, it's curve, right? So it tells the curve that we go over curve, and it's like length 100. And if I go and continue, right, here now I am with the solid. And again, when I do this, now I hit the geometry element. And probably the geometry element is not something that I want. I just want to get all solids. And that's probably because our like element is pretty complex and that may have a lot of these branches, right? So if you think of this as the tree, where you have the root element, where you have different branches and you have leaves. So you want to ignore all these branches and stuff. You just want to get to the real leaves, right? To like curve, solid, and so on and so forth. So here you would need to do some checks, like is it like a geometry element on our way? If it is, let's go over this again. So you would do something like this. If what I go through is that, gosh, I'm typing on my laptop and I'm not used to it. And if that is geometry element, um, again, this one geometry object that we're going through. Yeah, if that is a geometry element, that is considered to be nested geometry element, right? And here you would go and say, let's go over this again. So we're going to go for each and so on and so forth. So you will get now, you will iterate over this nested one. And then you'd also say if this is geometry instance, right? What we do, and so on and so forth. I'm just showing this to understand so you can understand the problem that we have. Uh, The problem with this that is kind of pretty unpredictable. Like, let's suppose you just look at this structure, right? And you say, okay, I go over this. If that is geometry element, I should hit there and go inside of this part. And let's even go and do some silly and say like result. Yeah, that's kind of a dirty way of doing this. I don't like this imperative style, but we're gonna go over this right now so you can understand the problem. So if this is geometry element, so if we hit this, we gotta go inside there. And now it's like if that is geometry instance, because inside this we have a geometry instance there. So we gotta say if O is geometry instance, right? You gotta do like again some other things, and it'll be like geometry instance, get instance geometry again for each. And you have a lot of these indentations that are looking ugly. If you want, what I would recommend is that you do it yourself. Try to basically get by this part, just paste this portion and just add to this result geometry objects. So you can also practice this. I just don't want to show it do from scratch because it will take a lot of like the whole video will be too long. But this is the whole idea that it's pretty unpredictable. And the funny thing is that in this geometry instance, right? Let's suppose here I'm getting this geometry instance, which will return me curves and solids. I can here use new geometry element. So that's another branch. So it's pretty unpredictable here. It's like, oh, we need to check it again, right? So it's not stable because now we would need to do the checks here and say like geometry. Gosh, it also has like silly names. Is if that is geometry element, do again this loop, right? And as you can see, since that has this tree-like structure, it just doesn't work this way. So try to do this on your own, and that'll be pretty helpful. But what is our first functionality? That is to flatten a list. So flatten a geometry element. So I want to have a function that says flatten, and it will provide me only with the leaves. Let's kind of understand the terminology that we're going to work with. But I would need to kind of bring back the whiteboard so I can easily illustrate this. So I'm going to be back in just, for you, it's going to be just a second. So yeah, now we're on the on the whiteboard. So what I wanna, so we gotta stick to the terminology, right? It's very important. So what we understood is that we have this geometry element at the very beginning. So we have element, and from element we've got like geometry element, but then it's like a tree structure. So the first one, this one, right, that we got from element, that is called a root. So that is something that lives at the very top. So think of this as the tree, but it is kind of in the reverse order. I'm going to show you this in a little bit of an easier way to get it. So GA stands for geometry element, so I don't need to spell it, spell the whole word. So then it may contains like if we go and check what we have there, like this one, we have curve, curve, and then we have another geometry element there. So it right now, oops, uh, gosh, it's pretty. Where is it? For God's sake, where is it, guys? Do you see it? Okay, for some reason, okay, we have curve. Then we have another curve, and then we have another geometry element that kind of goes there, and it has, for example, another curve, then it has geometry instance that has like curves and solids, for example, right, curve, solid, and so on and so forth. So these things that actually has these things that have that have children, right? Because geometry element have children like at the very top level, that is root. But the ones that are below root, these are parents. Parents because they have children. So these are parent, right? Parent. And things like curves, solids, like this curve, they're all considered leaves. So this is leaf. Gosh, what happens with my spelling? These are leaf leaf, right? And in plural, there will be leaves. So again, it's English. It's very doesn't make sense, right? Why it's not leaves just with an s at the end, but again, that's English. So yeah, leaves are going to be these parts that don't have any children, right? Curve doesn't have any children. Curve is actually at the end part of our tree. Why I said that it's like a reverse tree, because usually trees, like when you have a root, something there, then you have a tree, right? You have various like branches, and at the end you actually have some leaves there, right? Some leaves like that again. I never thought I would do something like that. Okay. But again, that's the idea, right? We have something at the root, and then we have various like I don't know, again, some leaves, some branches, and we end with the leaf. So you can think of these branches as geometry element or geometry instance, and we're only interested in end parts. So this is what we have. Let me move my tablet a little bit out of the way because it's kind of, yeah. So this is the whole idea. So we're on the same page. So our main goal is to get just leaves. So this is the so with the TDD approach, what we do usually is that we write a list of task cases that we want to choose. Then we pick one, then we write tasks, right? We make it pass and we refactor this and we go in this flow. Again, everything will get clearer once we go. So let's gonna go with the task that we want to do. So I'm gonna just copy something there. So this is the naming convention for the method that will contain the test. We'll see that what method name we want to check, what condition, and what we expect as the behavior. And as the name, I choose this one. So, and I want to say when. Flatten, that's the name of the method that we will test when multiple level nested geometry elements return single flat collection. I like this one. So let's copy this. Let's go to our code, and I'm gonna rename this method. I'm gonna click, okay, I can just do it like this and just rename this. So now this method clearly identifies what it checks, what it tests. Um, I also want to change the name of this class. Again, these classes that are task classes, they're just like containers for storing some coherent, cohesive tasks, some tasks that make sense to stay together. So I'm gonna click Control RR. That's in Writer. That's a way to rename things. Why I'm not just renaming that here without using this function, because it won't change here that unit test one. So I'm gonna name this as, for example, for the time being, geometry element tests, right? And click OK. Once I do this, as you can see, it updates it here as well. So that's why I went with this approach. Okay, so now let's see what we expect there. So what I expect there, because again, I've prepared something because unfortunately cannot memorize all that info, right? So what I expect is that usually we go with tasks are written using this pattern, arrange, act, and assert. So first thing, we're gonna grab this one. You can click in Writer, Shift, Alt, and equal to kind of select it this way. So it allows you to quickly select things inside, things outside, right? And I can click Alt and just move it up. So that will be for the arrange part. So I'm arranging what I need to test. Here I will act on it, and I will name this var expected result, right? It's not expect, it's actual result. So what we have there. So we're gonna have geometry element, and we're gonna have a method called flatten there. So this flatten method is purely, again, we don't have it yet, right? We don't have it yet. That's about these steps in the testing that you're just thinking about what functionality you want to have, and the first thing you just make it rad, right? So it doesn't pass it in. For the time being, I'm gonna put there and say I want to return out of this IEnumerable of geometry objects. So this is what we have there. And then once I have this actual result, that's when we need to do assertions, right? So we're gonna go and say, um, I think we already installed, right? I think I kind of made it clear that we gotta install Fluent assertions. Fluent, everything that is Fluent is always awesome. Fluent is basically this chain calls that are written as if it's just like English sentence, right? That's what I really like about this. So we can go actual result and we can say should have count. So we should check if this result that we retrieve have a given count. So how many elements we expect this enumerable to have. We have 1, 2, 3, 4, 5, 6, 7, 8. Again, we don't want to get these branches. Again, think of this tree that we drew. We don't want to get these branches. We just care about these things. And also we can chain it with other things. And also we can say and all satisfies, so that allows us to write it like this. And inside here, we can say that each of this part that we get, this geometry object, it should not be of type geometry element, right? Oops, again, geometry element, and not be of type geometry instance, geometry instance. Something like this, and let's even make it look like that, right? So it really nice. Why I said that I love this fluent way, because now we can even do it like this. So whatever result we're getting, again, there's some function that we currently don't have, right? But the result, this is what we expect from it. So we expect it to have count of 8, and each of them should not be geometry element and geometry instance. In most cases, I would check if there are sequence equals. But here, what I don't like is that, again, that's the reason why we kind of created them as classes. And when we check them by default, it makes them equal by reference. But usually, again, it's too deep in terms of TDD things and their value objects. The fact that they're like value objects, meaning that when we compare things, for example, when you compare curve and curve, you don't worry about them being somewhere stored in you don't compare them by their address in the memory. You compare them by their values. And these what records are really great at. So this is what I showed you. For the time being, since we're just kind of playing around with this, I'm okay with leaving this as this. But now what you should see is that we have an environment where we can test it. And right now, again, we have a test, we have a name for this. Now it doesn't work, so we gotta make it at least work. Let's create public static class geometry element extensions, right? And here we're going to say public static IEnumerable of geometry objects. We're going to name this flatten, and we're going to do this on the geometry element. When I use these kind of extension methods, right? Extension methods allow you to call methods on these objects, so you can kind of add methods to the geometry element instance. But please, again, let me show you first and then I'll explain. Geometry element. I like to call this geometry element or self, like this. That's also cool. But let's leave it as this. And let's for the time being say through new not implemented exception. So now everything compiles. And I can even make it var right now. I like to use var. So now because it's clear for the compiler that we're returning IEnumerable, because now if I click control and I navigate to this method, it just navigates me there. So this is what we have. Um, what is really important here is that this one allows us to, as you can see, when we follow this syntax, when we have a static class and inside this we have a method with this keyword like this, that's a special syntax for adding functionality to some classes. So imagine that's for Revit because usually this geometry element is not going to be accessible to you. So you want to have this feeling as if you call this on that instance. So you can create extension methods for this. So as you can see, we can add functionality without actually touching this. But please keep in mind that extension methods have different semantics. They have different purpose than just adding functionality to the instance of some class, right? That's what's really important to understand the semantics of this, what it actually means. So don't think that it's as if I'm adding new functionality to this class. It's not. Later, it will be just replaced as the static method. For example, like geometry element extensions, right? Flatten, and that'll be actual result. Not actual result, but geometry element. This will be replaced like that. So the main idea is that using these extension methods allows us to have this fluent way where we kind of read what line by line instead of having this nested calls. So okay, so that's kind of cleared out. So now we have it, so we can test it. So I can say, let's run all tests. And what happens is that it's not gonna work. It's gonna fail, right? It's gonna tell that one or more children test failed. Since we have only one, I think we gotta go there. And then we say that the reason for this is that it throws an exception, right? And that's not something that we expected. This is what we expected. So this is the moment where I want you to stop and try to understand and try to solve it on your own. So create implementation for this here. So just understand that we should result in IEnumerable that will have curve, solid, curves, curve, solid, 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 curve without these branches. So this is what I want you to do now. So if you really want to learn something out of this video, not just watch it, because believe me, programming is all about being practical. It's all about being making sure that you practice a lot, as opposed to just watching tutorials and getting into this tutorial hell and you're not able to solve problems. So that's why I'm trying to kind of find a different approach of teaching. So now you understand requirements. Requirements are clear. We have this method that should return us an IEnumerable of 8 elements that are not geometry element and not geometry instance. All of them are leaves, right? We don't want to have any parents and we don't want to have roots. Yeah, so this is what's really important for you. So I hope you will do this on your own. And again, for you, it's going to be just a second, but then we'll go back and implement it on our like from scratch. Thank you everyone for watching. As always, like the video, subscribe to the channel, leave some comments down below. I would really appreciate it, and that would help the channel grow. Again, thank you for sticking up to the very end, and see ya.